All right. Let me put the mic on. Welcome back, everyone. I'm going to talk to you about platform choices. When you get to x86, there's a lot more things to choose from than there were on Alpha or Titanium. So let's talk about some of those choices. I want to go a little bit into OpenVMS and virtualization, and then we'll talk about choices in hypervisors, hardware, virtual devices, and finally I'll have some slides about clustering and shared storage. So OpenVMS and virtualization. Running on hypervisors, you can run OpenVMS on the most commonly used data center and desktop hypervisors. That's our goal. We want to support things like VMware ESXi and KVM that are in widespread use in data centers. And on the desktop, we want to run in VirtualBox and in VMware, what's it called? Fusion on the Mac, and then the other one is a workstation. That's the word I was looking for. And that's something, of course, that by now we've pretty much achieved. When it comes to hardware, our goal is that OpenVMS is completely independent from the underlying hardware, provided, of course, that the CPU in your system meets the minimum requirements for OpenVMS. But it shouldn't matter whether the system is running an Intel or an AMD processor, whether the storage underlying your bare metal that the hypervisor runs on is SATA or SAS or Fiber Channel or iSCSI, whether the interface cards were made by Broadcom or by Intel or whoever. So third of our objectives with virtualization is to be able to run OpenVMS in the cloud. And we want OpenVMS to be available in at least one prominent public cloud provider. And this is something I said in the previous presentation. OpenVMS shouldn't be an island any longer. There's no reason, there should be no reason for OpenVMS to remain the only isolated box that still has to be in a data center, still has to sit on hardware of its own. So how do you choose which hypervisor to run on? There's two different types of hypervisor. There are type 1 hypervisors, also called native or bare metal hypervisors. These are the hypervisors which you typically find in a data center. Examples of those are VMware vSphere ESXi, KVM, Xen, and Microsoft Hyper-V. And they are hypervisors which run directly on the hardware. In essence, the hypervisor contains a small operating system kernel that's really tailored towards its hypervisor function. The other type of hypervisor out there are type 2 hypervisors. These are based on, they run on top of an operating system. And they're most often used by developers who use them to run virtual machines on their desktop or on a laptop. And examples of those are VMware Workstation and VMware Fusion, Oracle VirtualBox, Microsoft Virtual PC. And this is the one that, of course, that you would find in a data center. On Integrity, we had HPVM. That was a type 2 hypervisor running on top of HPUX. And This is, of course, the first virtual platform that OpenVMS ever ran on. So we've done this before. So you notice that I've put 4 of the hypervisors in this slide in a bolder font: VMware, KVM, and VirtualBox. And I did that because those are the hypervisors that OpenVMS runs on today. So I'm going to focus on those hypervisors in the next few slides. So let's begin with the type 1 hypervisors. There's VMware ESXi, and then I've put 2 different flavors of KVM on this slide. There's Red Hat Enterprise Linux with KVM, and there's Oracle Linux with KVM. The reason I've picked those 2 is because we are working towards publishing a list of supported hypervisor platforms and best practices on how to set up those platforms. And these will be the 3 platforms that we are going to officially support. Right now, all you are getting from us, and this has been the case for too long, I think, is a list of hypervisors and combinations of KVM and Linux that we have tested on. We want to take that one step further and provide you with a list of things that we actually can support and give you some guidelines on how to set up those hypervisors. So VMware ESXi is a paid closed source hypervisor. And especially after Broadcom took over, for a lot of VMware customers, the prices have skyrocketed. Because VMware now, or Broadcom now, only sells VMware products as part of bundles that include a bunch of stuff that a lot of VMware ESXi users don't really need or use. So we've seen an increased interest in moving to KVM. Customers who were well on their way, and we were working with them to get their environments running on ESXi, we see some of those customers switching gears towards one of the KVM solutions. So Red Hat Enterprise Linux is like it's almost like the father of most Linuxes out there. And it's the one that most frequently comes up in conversations with customers with regards to what version of Linux they want to run in their data centers. So we feel that it's important that we support Red Hat Enterprise Linux with KVM. Now, you can run Red Hat Enterprise Linux without paying for it, but you get a limited functionality, and it's kind of difficult not to pay Red Hat if you're running Red Hat Enterprise Linux. Oracle Linux KVM is actually a derivative of Red Hat Enterprise Linux. It's Red Hat Enterprise Linux with some Oracle additions, particularly around the virtualization space, but also it comes with the Oracle Unbreakable kernel, the Unbreakable Enterprise kernel, which is a replacement for the Red Hat Linux kernel that has a stronger focus on security features. Now, for Oracle Linux KVM, there are pretty much no restrictions when you run it without paying for it. You can get a support subscription for it, which is cheaper than the Red Hat subscription, but you don't need it even if you want to run it in a commercial environment. Jared will probably correct me if I'm wrong there. So when it comes to manageability of these systems, VMware ESXi is pretty easy to manage once you figure out all the bells and whistles in the GUI. Red Hat KVM is a little more difficult to manage. It's more than on ESXi. You'll find yourself editing some text files to make changes. And Oracle Linux KVM, in my experience so far, is somewhere in between the two. You can do a bit more with the GUI that you get with Oracle KVM than you can do with the one on Red Hat. Particularly, like one of the things that I like to experiment with is setting up a cluster of machines and do things like move a virtual machine from one host to another. It's possible with Red Hat Enterprise Linux, but you need to pull in a whole lot of other bells and whistles from outside to make it possible. Whereas on Oracle Linux KVM, they have like a cookbook that you follow, and it makes it fairly simple to set that up. There may be things that I have missed in Red Hat KVM, but that's been my experience so far. I see someone.
Yeah, so if they both kind of proprietarize their interfaces to KVM to that extent? Because normally KVM is like you can move it around all over the place.
I think that's what Oracle has done is they have a virtualization manager tool that speaks to like multiple hosts at once. And there may be something similar for Red Hat KVM, but I couldn't find it that easily.
It is not just generating the XML definitions, grabbing the QCal file, moving it over here, and bringing it back up.
It's the
What I
Oh, yeah, Dockers.
there's a GUI where you can like right click.
Yes.
With Oracle Linux, there's a GUI where you can right click a virtual machine and say move it to that host in the cluster.
As long as it's another one.
It does have an API, right?
Yes. Yeah.
For Red Hat, it also has VM Manager. It is probably not full-fledged solution, but it is there. And by the way, there are another Red Hat kind of implementations fully compatible with Red Hat, which are completely free.
Right.
Yeah.
Like Rocky Linux, which you approved as well.
I had just assumed that Red Hat and Oracle would be the same as Debian. You just like roll over.
Okay, so when it comes to hardware compatibility, VMware has a hardware compatibility list it's got a lot of hardware on it, but they tend to be pretty quickly to drop support for somewhat older hardware. So for instance, I have in my home lab, I don't have the latest of the latest. I've got some Gen 9 HPE blades in a C7000 chassis, and I figured that would be the perfect platform to build an ESXi cluster on. Well, it's not supported. It works, but you get all sorts of warning when you boot telling you that you're running on an unsupported platform. Red Hat Enterprise Linux has a much larger hardware compatibility list, and once hardware gets onto the list, it doesn't drop off as easily as it does on the VMware list. And then Oracle Linux, for their unbreakable enterprise kernel, they've got a smaller list of supported hardware. But if you disable that feature, they say that they support the same hardware that Red Hat does. So with Red Hat and Oracle Linux, you have a larger variety of hardware to choose from than with VMware. I found that KVM averagely performs slightly better than ESXi in some of the benchmarking I've done. Your mileage may vary a bit. It's not a huge difference, but it's in my mind, it's noticeable. And then when it comes to high availability features, clustering hosts, doing like if a host needs to be shut down, automatically move things to another machine. When you start up a virtual machine, start it on the host that is the least busy. This is all possible in VMware ESXi, but it requires you to be on a higher license tier. So there's an additional cost involved with that. With Red Hat Enterprise Linux, it requires some extra software. And then with Oracle Linux, you basically get it when you follow that cookbook, you get these features thrown in. Any questions? So which one you choose, of course, becomes the question. In my mind, if you have an existing ESXi cluster where all your other workloads are running, I would run VMS there. If you're already heavily invested in KVM infrastructure, run it there. If you're new to running on virtual machines, I would start with KVM because it's just a lot cheaper to run on. And in my mind, it's a bit more flexible. The amount of options that you can configure through the particularly through the XML files to define the virtual machines can be a bit overwhelming and mind-boggling because ESXi hides more of the complexity from the end user and often provides you one or maybe two ways to achieve a certain thing. The nature of some of these open source projects is that if there are 20 different ways to do a certain thing, you can use all 20 of those ways if you know how to do it and how to configure that in your XML file. So we'll be providing some guidance around what we have and haven't tested there. When it comes to the type 2 hypervisors, the kind you run on your laptop or on your desktop system, again, VMware is paid and it's closed source. VirtualBox is free open source with a little exception. VirtualBox comes from Oracle, and if you just download the base VirtualBox package, you're running free open source software. There's also an extension package that you can download. And then you're running some sourced closed source edition to enable some extra features in VirtualBox. And then there are some restrictions like you have to pay for it if you want to use it commercially. So be careful when you run VirtualBox. If you want to use those extensions, you have to pay for them, unless it's like completely like a hobbyist project.
VMware workstations free now in January.
Oh,
That was the change. It wasn't
for personal use. Okay. Okay. I hadn't realized that.
I don't know about that. Workstations.
Yeah.
On VirtualBox, one of the extensions is to share folders, share files outside the environment. Does that work with VMS?
No. No, I mean, there's very little in the VMware extensions that is of use on a VM system, VMware or on the VMS system. Yeah.
Where do you put KVM running on top of Ubuntu?
Well, not on this list because these are type 2 hypervisors, but no. Well, KVM doesn't run on top of a Linux. No.
Yeah, come tonight. I'll show you.
It's in the kernel, and it inserts itself underneath the operating system, and you'll end up with Linux running on top of KVM. The part that runs on Linux is QEMU, which is the device virtualization that KVM then makes available to other operating systems running on it. But KVM inserts itself as a layer under Linux.
Yeah,
Yes.
that's closer to the hardware. Yeah.
Yes. If you're running Linux on your laptop, I would absolutely 100% prefer using KVM over using VirtualBox.
Oh, yeah.
Oh,
Speaking of which,
now your explanation makes sense. I didn't realize that.
Okay.
so
Thank you.
Yeah.
Come by anyway tonight.
Welcome.
Hyper-V was not one of the golden.
No,
Was that just because of resources or?
I'll get to that in the next slide, actually. So VMware Workstation has way better performance than VirtualBox. This is a big difference between those two. VMware Workstation, this is one I haven't put on this slide, but VMware Workstation plays well with Windows 11. VirtualBox, you have to go through some hoops to make absolutely certain that you've removed any trace of Hyper-V. And that is more difficult than you think, because even if you have turned off Hyper-V in Windows 11, as long as you're using any of the virtualization-based security features, you're still running Hyper-V, and VirtualBox will not run, OpenVMS will not run on VirtualBox if it runs on top of Hyper-V, which is,
Microsoft Mobile.
it's more of a VirtualBox problem, to be honest. I find Workstation a little bit easier to manage than VirtualBox. I think the GUI is a bit more consistent, but that's more personal preference, I think. So we'll get to why no Hyper-V support. There's a big difference between Hyper-V and other hypervisors. So if you take almost any hypervisor, that hypervisor provides emulated devices and emulated controllers. That means that they provide a network interface that looks to the operating system running in the guest OS just like a real network card. And it provides a disk controller and a SCSI disk that looks just like a real SCSI controller. They also optionally provide para-virtualized I/O interfaces that allow you to speak on a more direct level with the hypervisor to do things like network and disk I/O. But because it provides those emulated devices, you can boot an operating system on these hypervisors that uses standard device drivers. You can almost completely hide the fact that you're running on a hypervisor from the OS because it looks really like real hardware. That means that once you've got that running, you can get the system up and running with device drivers that were written for real hardware. And then you can use the platform running with those real drivers to develop your virtualized drivers to take advantage of the higher I/O capabilities. Hyper-V is a completely different beast. Hyper-V, there was a version 1 of Hyper-V and a version 2. Version 1 was like the other hypervisors. Unfortunately, VMS cannot run on a Hyper-V 1 virtual machine because Hyper-V 1 doesn't offer the UEFI firmware. It only offers BIOS, so we cannot run there. And Hyper-V Generation 2 virtual machines are purely synthetic virtual hardware. They only provide virtualized I/O interfaces, and their virtualized I/O interfaces are different and require different drivers from the virtualized I/O interfaces available on other hypervisors. So this means that you cannot even boot on Hyper-V before you have developed these virtualized drivers, which are kind of difficult to debug if you're not running on Hyper-V. It's like the chicken and egg problem. And we've just decided that it's not worth our trouble, certainly not at this point. Maybe by the time that we've completed all the bells and whistles that we want to complete for VMware and KVM, we can take another look at running on Hyper-V. But for now, we don't see the point in it. I hope that answers your question. Yeah.
OpenVMS x86 client for KVM.
x86
Client for KVM. An OpenVMS client for KVM. The client,
you mean like
do backups with where you can back up data in transit.
Right, it's like the equivalent of VMware tools or part of that. Yeah. We're looking at that kind of functionality, but we're beginning with some of the basics like timekeeping, and we'll figure out what sort of like host guest interaction mechanisms that are available on the different platforms make sense to implement in VMS. Some things just don't make sense. We don't run VMS with a graphical user interface, so the ability to drag and drop files from the host to the guest on OpenVMS doesn't make that much sense. Do we want to implement some sort of like command line based mechanism for that? Probably not. One thing that you should be aware of is the Oracle licensing implications of your choice of hypervisor. Oracle is basically saying, if you run on a virtual machine on a box, you pay for the cores in that box, because we cannot guarantee that it won't run on any of the other cores in the box. The only way Oracle allows you to license an Oracle product for less than the number of cores in the physical box underneath your virtual machine is if you run Oracle's KVM solution and enable, basically lock your CPUs, your vCPUs to physical CPU cores. This means that if you buy an Intel server today, chances are it will have something like 40 cores, or maybe even more. And Oracle will make you pay for every single one of those 40 cores unless you run Oracle Linux with KVM. In that case, if you create a virtual machine with 2 virtual CPUs, then you only pay the licensing for 2 cores. So this is something you should be aware of. Security considerations. You're running OpenVMS on a virtual machine. And just as on Alpha and Integrity and VAX, locking down access to the physical hardware is important. Because if you plug a terminal into the console port on a system, you can do whatever you want if you know what you're doing. The same is true in a virtualized world. You want to lock down access to your hypervisor. Because if you can get to the console of the VMS system, or if you can, through the hypervisor, get to the disks, things like that, you can wreak havoc. So what can you do to make a hypervisor more secure? Well, for KVM, you can enable security enhanced Linux in the Linux kernel. That helps. If you're running a type 2 hypervisor, which I would never do for a production workload, but if you were to do that, then securing the host OS becomes of vital importance. You want to lock down access to the Windows or the Linux that's running underneath that. And like I said, probably the most important thing you need to do is secure access to the OpenVMS console. If your console is an emulated serial port over a telnet protocol on your company's like main network, any employee in your company can connect to that port, hit Control-P, and boot with boot flag 0,1, do a conversational boot and become system manager. So try to use a protocol like SSH, or use a pipe to another virtual machine that you can only access in a secure way. Or use our guest console, which requires you to access the, you only have access to the console then if you are set up with that access in the hypervisor environment. Any questions about any of this? Okay, so moving on to choosing hardware. How do you pick what hardware you're going to run? First, how do you choose your hardware manufacturer? Well, in most cases, the hypervisor masks hardware differences between a Dell, an HPE, and an IBM system from the guest. We, in our lab and on individual developers' machines, we have run OpenVMS on a variety of hardware. I've run it on this ThinkPad laptop. I've used it on my previous company laptop, which was an Apple. I've used it on an Asus laptop at home. I've run it probably on 4 or 5 different brands of computers. Others have run it on other brands. And it just works. Whether it's VMware or KVM or VirtualBox, from the guest point of view, almost every system looked the same. The only thing that really still makes a difference is what CPU is in the box, because that gets passed through pretty much transparently. So pretty much all the major hardware manufacturers have systems available that are on the hardware compatibility lists for these hypervisors. So you may not be able to run, or not every HPE server may be supported with the latest version of ESXi, but there's certainly a whole list of HPE servers that are supported. And the same is true for Dell, IBM, Supermicro, you name it. So what it boils down to is that you can choose the hardware manufacturer that you feel comfortable with. If the rest of your company uses Dell for everything, you should be able to run OpenVMS on Dell. However, there's a but. And the but is if you are running Fiber Channel Pass-Through. This is a feature that we're introducing in version 9.2-3. And because we are now using this pass-through mechanism, we are talking to real hardware. And that means all of a sudden we care about what that hardware is. And our Fiber Channel driver was created for HPE branded QLogic HBAs. So those are the only HBAs that we support for Fiber Channel with version 9.2-3. And we've had a lot of requests from customers telling us, hey, can we do this on Dell instead and get the Dell branded QLogic adapters? And we just felt that the engineering effort it would take to support all those requests, because they weren't only coming from Dell, they were also coming for IBM servers, and they were also coming for Cisco servers that have this strange converged infrastructure with Fiber Channel over like a common switch that's used for both Ethernet and Fiber Channel. And that is basically one adapter that can do both Fiber Channel and Ethernet, depending on what you tell it you want it to do. I mean, the list of requests becomes endless. So, and this sort of ties in with what I talked about earlier when we were an engineering-driven organization. A lot of customers got told, yes, you can probably run on Dell hardware when it comes to it, or yes, you can probably run on that. And we've really had to dial that back. And one of the first conversations I had with Jan when I took up my role was about this. And it's like, we've been telling customers, yes, probably, but we've never been able to give any customers a firm answer. And we sit down and we looked at it and we decided the firm answer we're going to give customers like that is no. You cannot run on Dell. You cannot run on IBM, at least not with our support. We will only support this on HPE hardware. But we've also explained to customers why we told them that. We've explained that by saving those engineering resources that we would have put on supporting Dell, we can get to a universal solution, iSCSI, earlier. And that's just a better choice and a better way to expend our resources. Jim.
I spent a long time working for 2 HPE enterprise storage providers. This is the right choice because HPE does a very good job of putting all the pieces together, qualifying them and saying, this HBA, this server, this firmware, here it's supported.
Yeah.
They've got this whole thing called the SAN Design Guide, which last time I think 4 volumes. HP says, if you put everything together the way we tell you in the SAN Design Guide and it doesn't work, we will fix it. Back in the days when you used to have to pull different firmware packages to like update multipath in Windows, Microsoft had a really good habit of, version 5 today is not the same as it was yesterday. HP pulled all that stuff together, put it into private sets. You go to the HPA site, you get a set of stuff that HP has tested and said will work. This is a good choice.
Right. Yes. So with version 9.2.3, what we support is the SN1100Q card. Unfortunately, as we found that card is not supported in the Gen 11 platform, even though HPE at one point told us that it would. But it means that support for now for fiber channel pass-through is limited to an HPE Gen 10 platform with an SN1100Q card. We're going to add support for the SN1610Q card, which is a 32 gigabit fiber channel adapter that is compatible with Gen 11, and then we'll also support HPE Gen 11. We expect to officially release that towards June of next year. Moving on, how do you choose a processor? Are you going to go with an Intel or with an AMD processor? Pretty much any Intel or AMD processor produced in the last decade is suitable to run OpenVMS on. We have a little Python script that you can run to see if it's got all the necessary features, but there are only like the lowest of the low cost, like Pentium process. I think even those work, don't they, John? Oh, well, I think at some point we thought they didn't, but they ended up that they did anyway. There was a bug in our code. But pretty much any processor built over the last 10 years, and certainly the processors that you will find in x86 servers will work. If you have a more recent processor, it often has some more additions to the instruction set to do newer stuff or to help an operating system do certain things in a more efficient way. And OpenVMS can utilize features like that. We've got a few of them that we use, and we use them by picking different code paths in system primitives. If you look at a previous version or a pre-9.2.3 version of VMS, you would have noticed that there were different variants of the system primitives executable. There was a system primitive 0, a system primitive 1, a system primitive 3. That is gone with version 9.2.3 because we've basically, what it was, like every different variant of system primitives was for a different combinations of available processor features. And what it means is that if Intel adds a new feature, that means if we want to use it, it would have potentially doubled the number of system primitives executables on the system. That all takes space in the memory disk, where space is somewhat precious. So this was one of the last big changes I made before I sort of like stopped my development role and started my new role, is I basically put all of those different code variants into a single image and basically call those functions through a jump table that we update when the system initializes and sets like the correct routine addresses in there. So that's how we handle these different processor features. And then when it comes to cores, OpenVMS supports up to 32 cores. We pretty much have the code to support 64 CPUs, but we haven't done enough testing with that yet that we can comfortably say, yes, we support 64 CPUs. One of the aspects, of course, that you need to take into account is with more cores comes more synchronization overhead. So it may well be that going from 32 cores to 64 cores, the overhead becomes problematic. Rob?
Yeah, we probably don't want anyone running more than 8 virtual CPUs or any VMS instance. There appears to be significant performance issues. And I'm not saying it's a specific need at 8. In general, the testing has shown that anything over 8 is problematic. And I don't know if we've documented that, but that's our experience.
Does that depend on SCADA or the other thing is just?
No, it's literally just as to be able to, you know, it's the synchronization, right?
Oh, okay.
Right. So any questions about the hardware side of things? All right, choosing virtual devices. Yeah, oh, sorry.
Right now, in the release notes, you say if you're creating a KVM or a VM or a VMware guest, choose this CPU model, which I think is the older one. I think it's like processor 94 or something like that. There is a higher one available, and it does present some more features to the guest.
Okay.
I mean, what's VSI's take on being able to say you can choose the highest level processor that say KVM or VMware offers?
To be honest, that is what I always do. If it's available, I just choose like the host model, which is like whatever's in the underlying box, which by definition is the most you can support on that CPU. That's what I always pick. I'll take a look at our release notes. Thanks for that.
Okay.
It
may be the installation guide. It's in the section that says this is how you create a guest.
Yeah, well, one of the things that we want to do is like separate that information out from the installation guide and the release notes and put like everything that is specific to a hypervisor into a specific document for that hypervisor. And doing that is part of what we're doing to announce like these are the hypervisors that we support and these are the guidelines on how you create a configuration that we can support.
It's because of our friend the AVX instruction set.
Right. Yep. So types of devices in a virtual environment. As I've talked about before, there are emulated devices. And those are devices that the hypervisor emulates to look like an actual device. So even if the NIC in your host system is a Broadcom NIC, the hypervisor provides a device that may look like an Intel E1000 NIC. And the hypervisor provides a SATA controller or a SCSI controller that looks from a software perspective just like the real thing. Hypervisors also provide para-virtualized devices. These are things like VirtIO-Net on KVM, VMXNet on ESXi, and VirtIO SCSI, which are, if you look at an emulated device, what happens is it exposes the same kind of register set that a real device has. So you have your memory in your virtual machine and say that contains a network packet. When you want to send out that network packet, you basically tell the emulated NIC, hey, there's a network packet in memory for you there, go fetch it. And then the emulated NIC needs to fetch that from the memory from your hypervisor, put it into some memory into this emulated NIC, and then it can go out on the wire. A para-virtualized device basically shares a memory structure between the virtual machine and the host. So you set up a buffer for communication between the virtual machine and the host. You do that from the guest OS, and you tell the hypervisor, this is where the buffer is that we're going to use for network traffic over this emulated NIC. And you just put network packets into a linked list there, and the hypervisor picks them directly out of the virtual machine's memory and transmits them on the network. So it doesn't have the overhead of emulating a device and putting something in a register, interpreting that. It's a much more direct interface. So these para-virtualized devices can provide faster speeds, particularly for network traffic, but also for disk traffic. The reason I say particularly for network traffic is because on the network, it's like the time it takes to hit the wire is probably the largest factor in latency there. With disk, there's also the processing time on the disk itself that probably sort of like dwarfs the time spent in this emulated device. There's also in hypervisors often the possibility to use raw devices. And this is where you take a real hard disk, which is where it's most commonly used, and you take that hard disk and treat it as though it were like a virtual disk attached to an emulated or a para-virtualized controller. So you have a real device and a software constructed controller, and it acts like that device is directly connected to that controller. And then finally, you have pass-through devices. And we use that with PCIe pass-through, which is where you put a controller in the host system specifically for use by one VM. And you tell the hypervisor you're not to touch that device, but you to pass it through to the virtual machine. This only works with type 1 hypervisors that run like on the bare metal. And it uses virtualization features that have been added to modern processors and modern IO MMUs, where you can basically, the hypervisor can tell the hardware, this now sits sort of in its own memory translation domain that belongs to this virtual machine. And that allows the virtual machine to treat that, to talk to that PCIe controller just as if it were running on bare metal and the controller was in the bare metal. So this means that if you put a QLogic fiber channel controller in your host and pass it through to OpenVMS, when VMS does the IOs to the controller, it's talking to the real controller, and the hypervisor doesn't play any role at all anymore beyond the initial setup. It's got a few drawbacks. As you can imagine, if you're sitting on a virtual machine talking to actual hardware in the host, you can no longer use vMotion to go to a different host. The other thing is you can tell that controller, I want to do a DMA transfer to my memory here. Now, because the host OS has no control over it, the hypervisor has no control over it, the hypervisor doesn't know which bits of memory might be hit by a DMA transfer you request. That means you need to tell the hypervisor to lock all of the VM's memory in place. That means if you give your OpenVMS system 8 GB of virtual memory, you need to tell the hypervisor reserve the entire range of memory, which means that means something for how you size your host machine. because you cannot, if OpenVMS is only actively using like 2 gigabytes of that memory, the host will still occupy all 8 gigabytes of memory on the host. Now that we get to clustering and share it, any questions so far? Okay. Clustering and shared storage. This is an image I took a while ago, and I see that I've only got 9 minutes left, so I'm going to speed up a little. Took this a while ago. It just shows you that clustering x86 with Alpha and Itanium works. However, for shared storage, we're currently only supporting MSCP. Question we get a lot, why do we need PCI pass-through to talk to a fiber channel disk if I can make that a raw device and use a raw device mapping to pass that through to VMS? Or why can't I use a VMDK file and make it a multi-writer shared VMDK? These are mechanisms that VMware provides to run, for instance, an Oracle RAC cluster or a Microsoft cluster. And the reason this doesn't work with VMS is because, unlike other clustering solutions, VMS has multiple systems writing to the same volume at the same time. Because our log manager doesn't work on a disk by disk basis, it reserves a range of blocks on a disk. And we've tried these mechanisms, and what we have found is that they work. You can create a VMS cluster, use a shared writer VMDK, and it works until you have any kind of transition in your cluster. If one of your hosts loses its connection for the disk, almost immediately things go to hell. Because VMS then starts figuring out, hey, is there an issue here that I need to be concerned about when it comes to the integrity of my data on the disk? And it goes to great lengths to figure out whether, to figure out whether there's a problem or this. There's a mechanism in the SCSI protocol called TCQ, tagged command queuing, which is basically a way to say, I've got an IO here and it's got to go to the disk before anything else anyone else has asked for. And while the TCQ is like emulated perfectly, it isn't transparent between hosts if you use these mechanisms. And what we have seen is as soon as any of the VMs thinks that it's lost the connection to the disk, even for a split second, which normally wouldn't lead to a mount verification, it then does all of its checking to see, is my connection to the disk still valid? And that fails. So you see like half of your cluster goes into mount verification. The other half of your cluster then gets like a cluster timeout and everything crashes. So don't do that. Just very quickly, 923, we support MSCP and we support fiber channel with these restrictions. I've talked about the hardware. No support for booting. The storage array needs to be on our approved list, which is the same as for integrity. I think that sort of makes sense. We'll have an update. Sorry. This says still the header is wrong. This is the update to 923, which will release at the latest in June next year. So this adds support for Red Hat Linux KVM and Oracle Linux KVM to our fiber channel solution. That would also mean no live migration on those platforms. Same thing as vMotion, just a different name. We'll add the 32 gig HBA and Gen 11 hardware support. And then in version 923, besides MSCP and fiber channel, we want to support iSCSI. And that would work on pretty much any hypervisor because it uses plain TCP/IP network traffic. That also means that now vMotion and live migration become possible again if you've properly set up your cluster for that. It means we can run clusters with shared storage in the cloud. It means we get rid of all the hardware restrictions on the host. Still no boot support. And for now, this is only planned for x86. We don't know if we'll be able to pull this off for Alpha or Itanium.
Do any of these things that you're doing in the future get you to a shared cluster system disk?
This by itself will not. But post 9.6, we want to end up in a situation where we can support cluster common system disks and booting from the SAN. And that will be then hopefully for both Fiber Channel and iSCSI. But we're not committing to any dates for this because this is a very complicated problem for us to tackle. So yeah, this is like a little overview. MSCP is available now, but it's kind of slow and you don't have direct access. A little bit slow. I've also heard some different opinions about that this week from people who have used MSCP over like 10 gigabit links. Maybe we need to quantify that a little bit better. Fiber channel pass-through will be available in December, but HPE only and no vMotion, and then iSCSI version 9.2.4 2026, and at least initially x86 only. So 3 minutes left if you've got one more question. Yeah.
I don't know, and this see a little bit of activity around Nutanix, the HCI, the one storage. Their solution also supports KVM running on ADP hardware. Did that ever come up at all? I'm just kind of curious.
Nutanix has come up, but we found that to even begin to try to run on to Nutanix, we had to spend so much money on hardware that it's Nutanix doesn't run on. You need like at least 3 host systems, and they need to have pretty large SSDs for a few things. And we tried it with hosts with normal drives, and it simply didn't accept it. It said, I really need an SSD for that, and I need an SSD for that. And we were like, if we're not going to throw $100,000 worth of hardware at something which may not work out in the end. So that's the story about Nutanix.
There's probably very few requests.
Yeah. Yeah. I think it's come up once or twice. All right. Thank you.